morning, children. Today we are going into the next part of the lesson. So yesterday what did we see? Yesterday we learnt two properties of magnet, isn't it? What was it? If we freely suspend a magnet, it will always stand in the north-south direction. And what was the second property of magnet that we learnt? We learnt that unlike poles of a magnet attract and like poles of a magnet repel. Now, we are going to learn how we can make a magnet. Can we make a magnet? Do you want to know how to make a magnet? Yes. So today we are going to try out whether we can convert a magnetic substance into a magnet. So we are going to convert a magnetic substance into a magnet. So we all have certain things with us, isn't it? In your kit, you have a magnet and you have certain magnetic substances. So I am going to take out a magnetic substance. So this is a blade, as all of you know. So this is a magnetic substance, isn't it? Why is it a magnetic substance? Because it gets attracted to magnet. Now can we change this magnetic substance into a magnet? Shall we try out? Yes. So today we are going to convert this blade into a magnet. For that we have to take this blade and we have to have a magnet in our hand. So I am taking a little bit stronger magnet and then using one pole. That is any one. Either it should be a north pole or the south pole. Please don't rub it together. So we have to use only one pole. So I am taking the north pole of the magnet. I am holding this blade in my hand and we have to rub it 20 to 25 times. Now how have we to rub it? Not this way. You have to rub it only in one direction. So using one pole, we are going to rub the magnet about 20 times. So I am just going to rub it. And when you are rubbing, you have to rub it only in one direction, not two ways. You have to rub it only in one direction. So can you see? I am rubbing it in one direction. So I have rubbed it many times now. Now we have to see whether this blade has changed into a magnet, isn't it? So how can we test whether it is a magnet? Yes, we can test by bringing another magnetic substance close to it. So I am bringing a magnetic substance close to it and we will see whether it is sticking. So I am bringing a pin close to it. Now you can see that the pin has got stuck to the blade. It is not standing for a long time because blade is a very light material and the pin is heavier than the blade. So that is why. Now you can see that it is sticking. So here we can see that the blade has turned into a magnet. So please try this out from your home. It is very interesting. Now, can we find out the polarity of this blade? Can we find out the polarity? What's the meaning of polarity? We have to find out whether this blade has got a north pole and south pole. So now we know that north pole and south pole is not marked on this blade. So how do we know the north pole and south pole of this blade? Or how can we know the polarity? Do you have any guess? Yes. Why? Because we already know which is the north of this room, isn't it? Yesterday when we did that experiment, we already know which is the north of this room. Which is the north of this room? This is the north. And where is the south? The back side. This is the south of the room. So, how do we find out the north pole and the south pole of this magnet? Yes, if we keep it, suspend it freely. It should come and stand in the north-south direction. So whichever direction it is standing, that part which faces the north of this room will be the north pole of this magnet. So shall we do that and see? Yes. So little more, let me rub it so to make it a nice magnet. Now I took a blade because it is easy for us to find out. So to find out that, instead of hanging, we can do another experiment. I have taken a beaker of water and I am going to put this blade into the beaker. Because the blade is very light, it will float on the water. So this is floating on the water, and now when it comes to rest in the north-south direction, that is the north pole of the blade. So I am just giving it a push once again. I hope you can see. See, now the blade is resting. Even after I am turning the blade, even I am turning the blade this side and that side. See, it is coming and resting in one direction. So, which one is the north pole? This side of the blade is the north pole and this side of the blade is the south pole. So, exactly like how it showed in the compass and it showed in the magnet. Yesterday the magnet was standing, isn't it, in the north and south direction. So the same way the blade is also standing. So now we know this is a magnet. We have made a magnetic substance into a magnet. Now this blade is a magnet. So this is the north pole of the blade and this side is the south pole of the blade. Isn't it very interesting? So you also must try to do this experiment. Okay. I hope you can see me. We have certain things here. So we are going to do another experiment. So now here we are going to find out the range of the magnet. So what is the meaning of range of the magnet? Every magnet has a particular range of attraction. So we are going to see the range of this magnet. For that I have taken few things here. I have stand, I am hanging a needle here. And then I have taken a scale and I have kept the magnet on top of the scale. Why is the magnet kept on a scale? Because I want to measure the distance. So from I have kept the beginning of the scale here and I have kept it in this distance here. And then what am I going to do? I'm just going to bring this magnet close to the needle. Okay, I'm going to bring the magnet close to the needle. We have to keep it like this. I hope you can see. Now I am slowly pushing this magnet close to the needle. Now see what is happening. When I am bringing the magnet close to it, is something happening? Yes, isn't it? The needle is coming towards the magnet. See, it is trying to come towards the magnet. So now this distance is 4 centimeters, as you can see here. So when it reaches 4 centimeters, the needle is slowly trying to attract the magnet, isn't it? See here, we can see that when I am pulling the magnet behind, it is going behind again. When I am bringing the magnet close, it is coming forward, isn't it? See? So here we can see when it is 4. So what is the range of this magnet? It is 4 centimeters. The range of this magnet is 4 centimeters. Again I am bringing it forward. So what is happening? Yes, see? Because it's down, it cannot attract. If it is little more, it will attract. So the range of this magnet is 3 centimeters. When I keep it here in 3 centimeters, that is from the distance here up till here, in that 3 centimeters, you can see the needle is coming forward. So this distance is called as the range of this magnet. So the magnetic force is there in this area. So this area is called as the range of this magnet. So I hope you understood. So what are the things that we learned today? We learned that we can change or convert a magnetic substance into a magnet by rubbing it with the magnet, and also we've calculated the range of each magnet. So another, if you take another magnet, the range of that magnet might be different. So the range of this magnet is 4 centimeters. So you can try this experiment using other types of magnets and see what is the range of the magnet, and find out whether the range of all types of magnets are the same. So this is the activity you have to do. Thank you, children.